Among Saturn's more than 140 moons, one stands out not for its size or beauty, but for what might lie beneath its frozen surface. That moon is Enceladus, a small, icy world only about 500 kilometers across, yet one of the most promising places in the solar system to search for alien life. At first glance, Enceladus looks like a featureless snowball, bright, reflective, and seemingly dead. But looks can be deceiving. Beneath that white exterior is a hidden ocean, and from cracks near its south pole, geysers of water vapor burst into space, revealing secrets from deep inside. These towering plumes, some stretching hundreds of kilometers into space, were first discovered by NASA's Cassini spacecraft. What Cassini found shocked the scientific world. The plumes were not just water vapor. They contained organic molecules, salts, and even tiny grains of silica, evidence of hydrothermal activity on the seafloor. In other words, Enceladus isn't just icy, it's active. Deep beneath its shell, there appears to be a global ocean of salty liquid water, heated by tidal forces as the moon flexes under Saturn's gravity. This heating may create environments similar to Earth's hydrothermal vents, where life thrives in total darkness, fueled not by sunlight but by chemistry. This revelation is enormous. On Earth, hydrothermal vents are home to entire ecosystems, worms, bacteria, and exotic life forms that don't rely on the sun. Could Enceladus support similar forms of life? Microorganisms that evolved in complete isolation, in a completely alien ocean. The Cassini mission didn't just observe Enceladus from afar. It flew directly through its geysers. And during those flybys, it sampled the material in real time. It detected complex organic compounds, some with carbon chains that hinted at prebiotic chemistry. One of the most tantalizing finds was hydrogen gas, a key ingredient for microbial life. On Earth, hydrogen feeds methanogenic archaea, ancient organisms that live in extreme environments. If similar life exists on Enceladus, it would survive deep in the ocean, feeding on the chemistry between water and rock. And here's the stunning part. We don't even need to drill through the ice to study it. The plumes are natural vents, delivering samples straight into space. Future missions could simply fly through and collect fresh material, like drinking from a fountain of alien chemistry. This makes Enceladus a prime target for astrobiological exploration. Some scientists argue that it is the best place in the entire solar system to find life beyond Earth. NASA and ESA have proposed missions, some involving orbiters, others landers, and even robotic submarines that could one day explore the subsurface ocean directly. But even without landing, a new mission could detect biosignatures, molecules or patterns that strongly suggest the presence of life. Beyond its habitability, Enceladus is scientifically fascinating in other ways. Its geological activity is localized mostly to its south pole, where a region known as the Tiger Stripes splits the ice with deep fissures. These ridges, glowing faintly warm in infrared, are where the plumes erupt, powered by a subterranean ocean under pressure. Enceladus also helps feed Saturn's E-ring, one of the planet's faint outer rings. The icy particles ejected from its geysers are caught by Saturn's gravity, forming a glowing halo that stretches around the planet. It's a perfect example of how moons and rings are deeply interconnected. And while Enceladus is small, it punches far above its weight. Its reflective surface makes it one of the brightest objects in the solar system, reflecting over 90% of the sunlight that hits it. Its internal ocean, sustained heat, and geyser activity place it in a league of its own among icy worlds. In the cosmic quest for life, Enceladus represents a rare opportunity. It has liquid water, chemistry, heat, and energy, all the ingredients scientists believe are essential for life. Unlike Mars or Europa, where accessing the interior is difficult, Enceladus offers its secrets freely through its geysers. At infinity beyond, we believe that Enceladus is more than a moon. It's a message, a whisper from the cosmos that life may not be unique to Earth, that even in the coldest corners of our solar system, biology might emerge wherever the right ingredients come together. What would it mean if we found life here, on a moon no bigger than England, orbiting a distant gas giant? It would rewrite the story of life itself. It would prove that the universe is not a silent void, but a living, evolving ecosystem of worlds waiting to be discovered. So as we point our telescopes toward the stars and send our probes into the unknown, let us remember Enceladus, not just for its geysers or its ocean, but for its potential to answer the most profound question of all: are we alone?